Okay, so here's a business and technical 50,000 foot overview of how blockchain works. Okay, so you wanted to go buy a car. Let's talk about blockchain and a car's life cycle. So there's a government agency that decides a new car needs to be built. So they say, well, let's create another one. We give authority to do that. They then create some paperwork that this is allowed and sends that paperwork to the factory, the car manufacturer. The car manufacturer creates the car, builds it, and says, yep, we built it, and records its VIN and all of that kind of details. And stamps that onto the car, and then lets the sales company know, hey, car dealer, we have a car for sale, and here's some paperwork about the car, its color and its VIN, and the authorization that we could build it to begin with. The car dealer then, you walked in there, and the car dealer says, hey, you want to buy a car? We have a car for sale. And they sell you the car. With the car, though, you have to register the tag with the tag office, and with it comes a whole bunch of papers to show you are the owner, and the VIN number and the color and the registration papers all comes with it. And congratulations, you now are the owner of a car. But if you look at this process, there's some paperwork over here by the government agency. There's some paperwork over here between, at the factory and everybody created. There's some paperwork over here for registration. There is a duplication, and, errors can easily creep in, and only certain people can see certain of these papers, so that's how it's sort of done today in a vehicle. There's this mass duplication of paperwork and information, and only certain people can see it. Now let's look at the blockchain. So if we look at the blockchain implementation of this whole process, the same government agency will say, well, let's create another car, like they did in the first scenario. But instead of creating paperwork, they are going to register this vehicle on the blockchain and say there is such a vehicle. The factory will get a notification that another vehicle is ready to be built, and they start building the vehicle. So they go ahead, build it, stamp it, decide the color, all of that, and they register all of that information onto the blockchain and say that this vehicle now exists and this is its VIN number. The sales team, dealer, gets an automatic notification that this car is available for sale. You happen to walk in and they sell it to you. And they say, congratulations, and the vehicle is transferred to you. But instead of giving you all paperwork, they just register on the blockchain that you are now the owner of this vehicle. And they say, congratulations, the vehicle is now yours. The tag office, instead of looking for paperwork and having a process with the dealer, and having to verify all of that kind of information, looks on the blockchain and sees that, oh yes, you are the owner of this vehicle, and it's a blue Ford, and it is its VIN number, and they issue you the tag, and you get the car. And congratulations, it's now your car. So as you can see, though, there is only one place where information went. It's on the blockchain. And there's not this mass duplication of information. If you sell the car, the blockchain gets updated. So it's sort of a central repository or object repository ledger, central ledger. Okay, now let's look at the physical implementation of a blockchain. A blockchain doesn't actually exist in one place, it exists in many places. And what typically known as validating and non-validating nodes. And these nodes intercommunicate with each other they directly talk to each other over what's known as a P2P network, meaning there is not a central authority. Each of these nodes can talk to another node, via the P2P network. So in the case of a government and the factory that creates the car and the dealer or sales people and the tag office might each have its own node, and the government will have a validating node, and a validating node can add a record to the blockchain. So can the factory. Once they created it, they can add or information to the blockchain. And so can the DMV when you transfer the vehicle and they need to register it. You can also have non-validating nodes, like for instance at the dealer or the sales office. They'll use a non-validating node to search and see what's available and which vehicles are available, and if they need to, they can let a validating node to actually put the transaction onto the blockchain. So the government in this case can put a transaction onto the blockchain, and the factory and the DMV, and they all do this through this process called consensus. So in our case, consensus really means everybody agrees that the transaction can be added to the blockchain. So in this case, once the government node agrees and the DMV agrees and the factory agrees, the record can be added to the blockchain. Just as a side note, in something like Bitcoin, they use a different consensus method, and that method's called mining, where to avoid everybody putting the latest transaction on the chain, they need to solve a big mathematical problem that can take up to an hour. And who solves it first gets to put their transaction onto the chain, and they get a little bit of coin in return for that. So that's just a side note. But then ultimately in this world, consensus for us is if everybody agrees. And then what it allows then as a developer to create an application for somebody like you and me or the guy on the street, who can then use a non-validating or that kind of node to search the blockchain, which vehicles are available, and find transactions. So anybody can create a node like that and get a copy of the data and be able to search and query it. So in this case, there is no central authority. Companies can join, groups can join, applications can join and leave without affecting. This data is everywhere, exists everywhere, but cannot be changed once it is written to the blockchain. Okay, so from a software architecture standpoint, this is how the blockchain is really built. And there's an event system or event stream down the bottom that it's all connected via events. So there's an event stream, and on top of the event stream is this chain code or smart contracts that can do things, and that's actual Java code or Go code or JavaScript code. Those are the three that's supported at the moment. And you write code, and that code goes with the transaction and is executed inside this secure VM container. And there's a registry for that, and there's a secure container on all of these validating nodes where this code of yours will execute the smart contract, or IBM calls it chain code. So it's important to know that that's one part of it. The other part of it is membership, meaning this is where you can register your identity, auditing exists. So a smart contract can say you must be a member of a certain group before you can do or see certain values, before you can look at something, or before you can do a certain type of transaction, you need to be a certain member or have a certain identity. So that's the second part of it, this membership, smart contract chain code. And then in the middle is, of course, the blockchain itself, and that's where the transactions live, the consensus live, the ledger, distributed ledger, and P2P. So, when you register a smart contract and pick it up and put a transaction onto a chain, and that's via the event. If a transaction's put on the chain, a smart contract can check the registry or the identity and make sure it's all interconnected and it's all via this event process, or event stream. So let's look at a physical. I'll show you quickly a Go program. So here's a simple Go program. I'm not much of a Go programmer, but this is by the Apache Software Foundation, and this talks about marbles. So a marble has a user, let's look at a marble first. A marble has a name, a color, a size, and a user. And like any other code, there's an init state, and then there's when it initializes, when it runs, there's a certain run invocation that a chain code can have, and it can have a query, so you can query it. So if you look at something simple as there's init marble, there's set user. Let's say you wanted to change the user, set user. All it's going to do is find the correct marble and then pop onto the blockchain, the transaction, changing the user, meaning changing it from one user to another. So there it is, the user is changed. All of these functions can be written, like I say, there's Java code, JavaScript, or Go at the moment. Here's, for instance, if you want to perform a trade, moving a marble from one user to another. And it's fairly simple. It really just goes move it, remove the old one, and register it to the new guy. And now there's still only the one object, but it now belongs to somebody else. Meaning we changed the owner. We didn't create a new object or something in the central registry. We've just changed the owner, and now the marble belongs to me. So that's sort of the thing around it. So it's very simple code. It's nothing crazy, and this is called, in IBM's world, is chain code. But in it's also known as a smart contract that executes and can do almost anything. You'll see in here there's, for instance, a delete, where you can delete a marble. Now everybody says you can't go back and change things. No, you're not changing things. The creation of a marble, the owner change of a marble, and ultimately the deletion of a marble will exist on the blockchain. Meaning those events that happened will be there, and you can't change the fact that the marble changed owner. You might delete it at the end of the day, but you will know before that who owned it and who owned it before that. The total history is written into this blockchain ledger and exists. So that's sort of a thing, the technical side of it. Have a look at the IBM Hyperledger project and the Apache Foundation's projects on this. They're all coming together, and this is an exciting and new world. Thank you very much, and we'll speak soon.